Okay, 2025. So yeah, I unfortunately didn't get as much time as I wanted to for this review. So I just threw together a couple of slides of the kind of high-level things that got done in 2025 because I think it's still worth just kind of briefly recapping. There were a lot of big things that happened in the past year, and I feel like you often lose track and forget about them quickly. So this presentation definitely doesn't cover everything we did in the last year. But hopefully it's kind of a fun reminder of all the things we did and how much can happen in 1 year. So if you all remember, except I guess for Rami and Jeremy who joined this year or last year, on January 1st last year, we started operating as a separate nonprofit entity, and so a lot of organizational work went into that in the beginning of the year, including setting up all the new accounts and subscriptions, paperwork, setting up our repositories, board of directors, press release, announcements, and everything around that. We also received our 501c status throughout the year, so had submitted the application, which was some paperwork, and then yeah, heard back from this later in the year, I think October or November. So now donations to the project are tax deductible, and we can get some discounts on our subscriptions. We have a new website now. Since we split from Nuenta, we'll set up this nice website for us, and it's been gradually evolving over the past year. There were loads of communications with various people in various industries and universities. It's just a collection slide. So some university collaborations, professors that we talked to or interacted with, students that we have projects with, like Loughborough University and Penn State, place where we gave talks, like the Chin Institute. Here's another student. Visited conferences like Alberta Reinforcement Learning Conference and Coxsci. Talked with people in the ultrasound space like Butterfly, Sonostar, Bloom Standard, GH Labs, IPRD solutions, for various aspects like hackathon preparation or building some proof of concept with Monty on ultrasound. Priya Panda USC through the Caddy collaboration. And yeah, basically turn so many kind of interactions and closer collaborations that we now have a spreadsheet to track them all. And then also presented the project at various venues like podcasts, talks at university groups, the RL debate series. Tristan presented at several places like Austin Robotics and AI Meetup, visited a conference, and in another podcast that Jeff went on. Scott presented at the Chen Institute. And so, yeah, hoping to continue more of that in the next year. We released 162 videos on YouTube. So yeah, we'll put a lot of work into processing all of these videos and publishing them. We have now 1,600 subscribers and like I guess 6,000 hours of watch time. We got 56,000 views in 2025. And yeah, it looks like it's been gradually increasing, especially after the preprints were released in July and after we started posting these YouTube shorts. Yeah, here's some example of the YouTube shorts. And then also the website views increased and became more global. All over the world, people are looking at our website, and you can see a bit of a kind of spike after either the paper release or starting to post shorts, or both. And similarly on Discourse, we've been seeing increased users, especially anonymous ones and a bit of crawlers as well. And then, yeah, all of you have been active on the Discourse forum. So yeah, thanks for all of you for posting these replies to people and having all these interactions. I know this takes a good chunk of time as well. And then we've been starting to get more substantial external contributions. This is just a random selection of things that I quickly found on slides. Will gave a nice overview of it during the meetup on the map. Basically, contributions on all aspects of the project now. People writing blog posts, proposing features to Monty, testing improvements like speed up possibilities, the video about Thousand Brains theory from Artem Kisarnov. There are so many blogs now that we started a section in our documentation, collecting them all, meetings and community working group meetings that we're publishing on YouTube, people contributing to future work items here on our roadmap, several people who are doing really larger chunks of work, helping us with our goals, and then also people starring our project and forking it. 270 people forked Monty by now, and we have 21 contributors to the code. And yeah, just some people sharing on the Discourse forum. We're not sure if there are other people who are using it and not sharing, but yeah, applying it to MNIST, Robot, AudioBot on phone, or at least thinking about it, some other projects. Will added this nice interactive future work widget to our documentation where people can now go and filter those items on our roadmap and see about contributing and read more about those items. And yeah, added more data and text to those. Everyone has been continually helping on improving our documentation. Here's just a random peek at how it looks now. There are images, videos embedded. There are a bunch of tutorials that are kept up to date. Added some documentation around reference frame transformations with animations. It's all of these pages have basically been updated in the past year, I would say, or almost all of them, or at least restructured and cross-linked. Tristan and Jeremy added some nice style guides around code style and typing to kind of help contribute code in the way that we like it. Niels added some language around large language model use. We have some more items in our project showcase now. The interactive future work roadmap, more descriptions on the future work items, and a new page around theory for object behaviors with various figures. Lots of documentation updates. Published the hierarchy paper preprint and submitted it to a journal. And obviously a lot of work went into getting the paper ready to be published, writing it all, getting all these figures made, and reviewing, adding references, all that. And then also the DMC paper, which we've had separate presentations about all the work that went into that. I know one slide doesn't do it justice, but published this as a preprint and got accepted into a journal. So that's been a huge achievement this year. And then also published research around the preprints, like explainer videos, blog posts, shorts, and so on. We had 2 retreats, one in California and one in Brighton, where we had a lot of fun and did a lot of stuff. We had 2 brainstorming weeks that were virtual with a lot of whiteboarding, and the robot hackathon in 2 locations where we built a lot of cool Monty demos. And I've made this a separate achievement because I thought it was really exciting. First time Monty moved its sensors in the real world and actually learned and recognized by moving real motors and sensors. So that was really cool. Um, and then I explored Monty for ultrasound further, made several write-ups, had a lot of meetings with various people about this, made this new data set, and published some tutorials on using Monty in custom applications, as well as documented the Monty for robotics projects as examples for people of how Monty could be used in real-world applications with some nice animations and figures and explanations on how to reproduce the projects we built. Uh, Lots of conceptual progress, literature reviews, and brainstorming. I mean, so many, it's hard to pick pictures for one slide, but there were just tons of write-ups, literature reviews, people making cool presentations, us just thinking on Zoom calls and having intense discussions. And yeah, I think we made some really significant progress on how to model object behaviors. We disclosed the initial idea earlier this year and some videos of how we got there, and then developed the idea further, concrete enough to have an idea of how we would want to implement this in Monty. And so we have a concrete outline of what to do to add this to this capability to Monty to model object behaviors. Rami added the ability for Monty to resample hypotheses quickly. So now Monty can quickly switch its hypothesis when we move from one object to another object. Before, Monty just couldn't do it, and afterwards it could do it really well. So that was a success. And then Rami added some more sophisticated ways of adding and deleting hypotheses, so the hypothesis space doesn't just grow a lot, but is actually quite small for most of the time when Monty is certain of where it is, and only samples once there's uncertainty introduced again, like when it moves onto a new object. And this is the exciting stuff that Rami and Jeremy are integrating into Monty now. Then made the compositional object dataset and metrics, so we have a way to evaluate Monty's ability to model compositional objects now. Prototyped saliency-based Saccade policy. So Scott worked a lot on this, detecting saliency, moving to salient points, and having some inhibition of return, so we don't just keep switching between the two most salient points. And did a lot of testing there, and also with Jose during the hackathon afterwards. And then Scott and Tristan worked on integrating a large part of this into Monty. So that was a huge integration project where sensor modules can now emit goal states, and there's a goal state selector. And then those goal states are sent to the motor system to move to. Jose prototyped the extracting of 2D features, so we can now detect like texture features instead of lettering on a cup just being like, right now we just detect the shape of the cup, like the curvature and surface normal, but now it can also, we have a sensor module that can detect these kind of printed things on there. We worked our way up to a Monty version 0.17. Tristan worked a lot on disentangling the motor system and allowing the swapping of policies. Here are just a small collection of PRs that went into that. There are more. And Jeremy worked a lot on the MoJoCo integration, Python update, and habitat dependency removal, which are all intertwined issues that are quite complex and entangled. And so here's, again, just a small collection of PRs that went into that. And then Tristan and Jeremy, during the focus week in November, switched our configuration management over to Hydra, and then also the weeks afterwards, finalized this process. And now we're using Hydra to manage our configurations, which was a big change. And many, many other improvements to Monty and Co. So 425 merged PRs, that's more than one a day, and 677 open PRs, almost two a day. And that's just to tbp.monty. We also have 29 repositories overall, and a lot of those had a lot of activity over the past year, like the feature branches developing some of the new research ideas, our internal infrastructure, the plotting tool, video processing tooling, and so on. Just showing a few examples here. TPP plot was developed by Rami, so now we have a really nice library of visualization tools. Tristan did a lot of platform planning. So yeah, you've all seen those nice breakdowns of all the items that need to go into building the platform. And we started a new prototyping process of where we build prototypes on a fork and then integrate them into Monty once they are proven. Organized the community event. And yeah, this was a slide I made, I think, February last year, of kind of the direction we were looking into, where we were looking into figuring out object behaviors. We didn't know how to model those yet. We didn't have any ideas yet, or not the one we have now at least. We were looking into removing the one episode per object assumption, so better unsupervised learning, which was a prerequisite for compositional modeling. So adding a testbed for that and adding policies and LM updates for this. And then on the implementation side here, various code refactors like data loader and dataset refactor, and making the motor policies more modular, as well as documentation and fostering the community. And yeah, looking at it now, we did a lot. So we added a lot of documentation and published videos, fostered the community, refactored data loader and dataset. Other refactors, the policy refactors are ongoing. Rami's changes removed this one episode per object assumption, and it works really well. We have a compositional modeling testbed and are working on all of these items here to do better on that testbed. We have a theory for object behaviors and have various ideas around all these other topics, or at least spend time talking about them. So light green is it's still in progress. But yeah, I think then made some good progress on all those, as well as all these other things I mentioned in the past slides. So yeah, great job, everyone. It's been an exciting year. Thanks for all the work you've been putting into this. Any questions before I move on to 2026?
I think it's pretty interesting just to see it again. At least for my old brain, I forget all this stuff. It's like, wow, we did all these things. It's really just in our first year. So it's pretty good.
Yeah, I agree.
Yeah.
Always feels more than you remember, and like especially when I was looking at the numbers today, like how many pull requests we made just to Monty, and like all the posts on Discourse and all the interactions and all the research prototypes and ideas we tested and features we added to Monty. Yeah.
Yeah, and I feel like a lot of the things are kind of building momentum in that, like from a technical perspective, a lot of it is about, being familiar with the code, being familiar with how Monty works and stuff. And then all the organizational stuff you were talking about, Vivian, like I guess a lot of that is kind of a one-off thing. So yeah, it's cool that we've kind of made all that progress, and then it feels like we could do even more than in the next year.
And really, this was, I know Niels and Vivian worked on this beforehand, but and well, several we did, but really starting a year ago, you can think of it that way. Starting a year ago with a running start, but still, there's a huge amount of stuff that was accomplished. And I guess starting this a year ago, you don't even know how it's going to turn out. You don't any of the issues. You don't know the organization issues, the funding issues, or anything. And there's so much to do and so much uncertainty. And it all turned out pretty good so far. I say this is an amazing accomplishments for the first year of an organization like this. Pretty impressive. Now we can worry about
Yeah.
next year.
Definitely makes me excited for the next year. Curious
I'm
how
always
else.
I'm always worried about the future. I'm always like, okay, yeah, all right, we did pretty well last year, but next year, who knows? Oh my gosh, I'm a worrier.
Hey, yeah, I think I'm pretty hopeful with like what Niels just said. It feels like a lot of things we've already put a lot of work into and are gonna kind of pick the fruits this year, basically. So, um,
I think that's right. Right.
pretty hopeful for the next year.
I'm always worried about, oh, what are the big things we missed? What have we not thought about? I think it's just my normal way of operations to always be like always worried about the future. And that's a good way to go because that keeps you on your toes. You never get complacent. You never sit there and go, oh yeah, we got this all figured out. It's like, oh no, what are we missing? But so far it looks great. It's like great. We had no real setbacks this year. We could have, but we didn't.
Yeah, I mean there are always a lot of unexpected things, a lot of issues we encountered that we didn't plan, especially with research. We don't know if things will pan out or not, but or especially also with developing the theory. But
Yeah.
it felt like we made some great progress with object behaviors, for example, and some much more clarity on some of these other
Right.
topics.
Right. All
So
right. The further you get along, the more of the pieces you fill into place, the less likely you're going to find some big hole that you're like, oh, we never thought about X, but it seems less and less likely. And so it does feel like, oh, we're filling in the remaining pieces.
yeah.
I've expressed my optimism before. I said, oh yeah, we're gonna wrap up the big theory things this year. If not, then the next year. But I'm hoping to do it this year. Um, so it feels doable. But you're gonna tell us what we're gonna do next year.
Yeah, we're gonna do just that. Wrap everything up.
Well, on the theory side, I think the other stuff is going to take a long, long time. Yes.
I just have one question. Jeff, you said no major setbacks. What would you have considered a setback?
Well, you don't know if it's one of these things you worry that, maybe like some deep theoretical mistake we made. Like, oh, it really doesn't work with reference frames. It works with something else. Or I don't know. It's like you don't know until it happens. But we have a whole bunch of fundamental assumptions we've made about Monty and the Thousand Brains theory. And they are proposed theoretical ideas. And in science, nothing's ever proven. And you can always, discover later, like, oh, we made a fundamental error someplace. Whether you think about like, Newton didn't get gravity right, but Einstein got it better, but maybe Einstein's wrong. There's always things you can get wrong, and you don't know what they are at the time. So um, I just always have to you always have to be thinking about that. You don't want to be caught like getting so far down the path and you realize you made a big mistake. So it's like Andy Grove used to say, it's the CEO of Intel. He used to say, only the paranoid survive. And I interpret that to mean like you always got to be worried about what am I getting wrong? What are we doing wrong? And I think about that all the time. And yet I don't see anything. But I don't stop thinking about it. Right? You just gotta, that's the way to be successful is you're always thinking like, okay, don't get complacent. Is there something I'm missing here? Or, what's the big idea? I don't know. I mean, I watched all the stuff of deep learning, try to figure out like, am I misunderstanding it? Is it more than I think it is? Is there something more fundamental going on there that I don't understand? I haven't seen that yet, but I worry about that. I still feel very confident that our approach is really the way to go for AI and machine intelligence. And but you worry about it.
I feel like that's actually,
So,
yeah, another interesting one where over the last year, I think there's been greater acceptance in the broad community that, deep learning, at least in its current form, isn't going to kind of deliver the sudden kind of fast takeoff to AGI or whatever that I think before then, there has been a lot of hype around that. So in
I
some ways, I guess that's another encouraging sign is that kind of at the same time as we've seen a lot of promise in what we're doing, more people have looked at kind of these and also predictive coding from a neuroscience perspective. there's been more and more skepticism. So it's kind of like one of the leading alternative theories in neuroscience and one of the leading or the leading alternative approach in AI have both had kind of a growing chorus of kind of skeptics, which
Right.
definitely doesn't prove that what we're doing is correct, but it is, I guess, an indirect signal suggesting that it's that we could be on the right track.
I feel like I think our work is successful not because, as you point out, it's true that, it's good that, if we're right, these other approaches we'll see holds on. But mostly I feel like, oh, this has got to be right. This is the way it has to work. You put all these pieces together. There's so many pieces fit together like this so nicely that there really can't be, that's hard to imagine them being wrong. And, but you just never know 100%. It's just, as much as you're almost certain of it, there's always skeptics. And I think one of the strengths we talked about this recently about, entrepreneurs and so one of the strengths is really having the conviction of your future vision and being certain of it, not just wishful about it, but being certain about it. And you have to plow through, despite the fact that maybe 99% of the world doesn't believe it and believes in something else. But it's it doesn't matter. If you're right, you're right. And so I always say, time is on our side. That's the way I look at it. Time is on our side. If we're right, time is on our side. The world will come around our view of thinking. So then I'm always asking, well, are we right? Is there anything we're getting wrong here? What's the big wrong thing we're getting? I can't see it yet. So maybe it doesn't exist. That's what's good.
Yeah, like that. The only real judge of things is time.
We're right, because if we're right, the world will come around to our thinking. You just hope it's not 50 years from now. You hope it's like 1 year from now. So we have to promote our ideas, and we also have to let these other approaches, whether it's predictive coding or deep learning techniques, that run their course until people kind of, there's a lot of people in the world who don't really have much of a clear vision about the future, and they just say, "Oh, this is the hot thing. This is going to have to work out." But over and over again in history of science and technology, you see that isn't the right way of going about it. The things that people thought were hot just fall apart after time. And you gotta stick with your convictions. And it's not just wishful thinking. We're not just like hoping this is right. I mean, everything seems like it has to be this way. Anyway, so I'm very, very confident. At the same time, you can be not pessimistic. You can be paranoid, or like asking yourself, "Oh, it could go wrong." And as you just ask, I don't know yet. We haven't seen anything wrong. It doesn't seem like anything's wrong. Constantly worried about it.
What makes me paranoid is that what you said about the current things have to run their course, is there's been an ungodly amount of treasure poured into the current things, which might really extend the time it takes for those things to run their course. That's what I'm paranoid about.
Maybe, or I think my observation is a different sort of course would run out. What might happen is everybody sours on all this, and it's not that deep learning is going to go away, but people might think like, oh, this is overhyped, and it's not, it's going to be. It could be in a year from now that people looking back at deep learning and thinking like, oh, this is ridiculous. They thought it was going to do all these things. It only does a few things. And then that could impact us because then nobody's interested in machine intelligence at all. And they go, yeah, that happened to me with mobile computing, right? There were some early failures like the Apple Newton. And then everyone said, oh, this is a stupid idea. No one's going to want a handheld computer. That's stupid. And no one put money into it. Zero. It all dried up overnight just because of some notable failures. So that would be something I worry more about. Like there's no, people just give up on this altogether as opposed to it takes forever for. The nice thing about deep learning right now is they're putting so much money into it. It's almost certainly going to have some big fallout of it. So I don't think it's going to be
right. Yeah, it kind of feels accelerated actually, because it's like without all that money in it, they can just keep saying, "Oh, scaling is all you need." But it's like if you actually draw the like finish the plot almost and like kind of say, "Okay, let's put all human resources into this," and it's like, "Oh, the payout's still not that great," then it's like, okay,
yeah, right. Yeah.
Need to revisit.
I remember the earlier wave of AI in the 80s and the early 90s when they were doing the what was it called? What was the technique they called then? The expert systems. And at that time, a lot of money was put into it, and people were reporting all the successes. In the press was all these, oh, they're using the expert system to do this and do that, and it's all wonderful, and it's really working. You could easily believe that it was going to be huge, but it all fell apart. Even though they said it was working. I mean, You know, and the current wave is a little bit like that. There's a lot of projects going on with deep learning that aren't really panning out. You know, everyone's excited about it, but there's a lot that aren't panning out, and some are, but a lot aren't. So who knows? We'll have to see. But I think we can be confident that our approach is right. There's a lot of things we can do that no one else can do. It's going to be ultimately successful. We just have to keep going and improve our stuff, and we have to let the other guys run their course and see what happens. That's life. But it's great. I feel like we're on the right team. So it's like, yeah, we're gonna win. This is race.
Yeah, it definitely feels pretty exciting.
Yeah.
Yeah, with that, let's talk about next year. So this is a bit borrowed from, or a lot borrowed from the diagrams that Tristan made that I showed earlier. So don't want to take all the credit for this, but I thought it was a really nice way to visualize things. It's a bit simplified. And feel free to interrupt if you disagree with something or have a question. But so our basic process right now that we developed over the past year or years is we develop some theory. Then the ideas that are developed in the theory turn into prototypes. So those are research projects that the researchers are developing on separate forks of Monty. Once a prototype is proven to work, so we actually show it does what we want it to do, turns into an integration project, and a researcher pairs with an engineer, and it is integrated as a Monty feature into the main TBP Monty repository. The more features Monty has, the better demos people can build with Monty. So if Monty has new features, new kind of demos can be built with Monty. And after building demos, those could be turned into actual applications, actual use cases, people deploying it in real world applications. We're not there yet. There isn't any kind of real world deployment of Monty at the moment. We dabbled a bit in demos during the hackathon, for example. And then there are some other arrows in between there, like if there are more Monty features, you can build new prototypes. Prototypes kind of build on top of each other. And then also as we prototype ideas, that can also feed back into the theory and reveal some issues we didn't think about, or some things that actually don't work how we thought they would work. And then we also have the platform quality, which helps on a bunch of things. If the platform is, and with that I refer to tbp.monty. If the quality is better, then it's easier and faster to build prototype. It's easier and faster to add features to Monty to do those integration projects. It's easier to build demos, and it's easier to build applications with Monty. That makes sense so far? Okay.
Yeah.
So our researchers are working on this part of the picture, developing theory, building prototypes, and then integrating the prototypes together with the engineers. And we've been spending a small amount of time on building demos, like during the hackathon, and some of the wrap-up work afterwards. And then the engineering team is not working on theory or prototypes, but working a lot on platform quality improvements, as well as the integration projects, and also we're part of building demos. Generally, this is how we want it to be. We don't want to spend our internal resources on building applications or even spending a lot of time building demos ourselves. Just simplified the picture a bit, remove some of the back arrows so it doesn't get too complex. There is another part of this equation, which is the community. So we have the community members, which can contribute to essentially anything. It's a bit hard for a community to contribute to theory, or at least it hasn't happened yet. It would require someone to do really deep dives and watch all our research meetings. Maybe people could test the theory in experiments, like experimentalists or something, but for now I didn't include that in the community box. But they can build prototypes, add Monty features, build demos, build applications, improve platform quality, and also promote the project and help us grow the community. And what really makes the community grow is seeing demos and applications. I mean, some people are intrigued by the theory and ideas, but what's really going to make Monty take off is once people start using it and seeing its benefits. So right now we don't have any applications and few demos, so most people in the community think this is a cool idea, cool project. But I think once people actually start using Monty in demos and seeing its benefits, then that will actually kick off this community growth a lot more. Not just like with LLMs, they were kind of an interesting thing in the research community, but then once people saw ChatGPT and could just play around with it and saw what it did, it really started taking off. It was like a simple, easy demo that led to a lot of growth. And once the community grows, that means that this whole green box has more and more resources and can thereby contribute to a lot of these other things more and more. And it's kind of this positive cycle. So what we really want to do is kind of kick off the cycle of the community growing and contributing back to a lot of this project, because if they're actually using Monty, they want to improve it. And so how could this tie into our goals for the next year? So some things that we want to do to encourage this is when making platform quality improvements, focus those improvements on improving the ease of building demos and applications. So, I mean, initially Monty was developed as a research code base. So it was initially built for building prototypes and Monty features, which used to be kind of the same thing because we didn't have this prototype feature workflow. So it was kind of built as a research code base, and now we really want to turn it into a platform that you can use to easily build demos applications. I mean, we don't want prototyping to get worse or harder in the process, but we want to focus the improvements on ease of use, ease of building demos. And then similarly with prototypes and Monty features, really think about, okay, is this a feature that will unlock new capabilities that's useful for building demos with Monty? So kind of focus on developing features that promise unlocking new applications. Those are kind of the big things that once we can model compositional objects, a compositional world, that unlocks a lot of new application areas. Once we can model object behaviors and things that move, that unlocks a lot of new application areas. Once we can actually use Monty's models to manipulate the world and interact with the world, that unlocks a huge range of new applications. So just kind of as we prototype and think about these things, think about, okay, what can we actually do with this? What does this unlock in the real world? And then lastly, this is a cool idea that Tristan had, which we termed Solutions Incubator now. It's the idea to encourage community members to build solutions with Monty. And I can talk a bit more about that right now, I guess. So the very basic premise, and we have to figure out all the logistics around it, would be to offer grants or stipends to people who come to us with an idea of something that they want to build with Monty. So basically, it's not like interns where they come and say, I want to do an internship in the summer, and then we have to come up with what they should do. But instead, they come to us with an idea. They pitch us the idea. And if we think this is a realistic thing that you could build with Monty, we provide them with a grant, some money, as well as some guidance, like meetings at a certain frequency. And they spend a couple of months actually building that demo and yeah, presenting it to us, writing it up somewhere publicly. And that way we have kind of idea generation from the community, people coming up with ideas that we would never think of ourselves, and kind of try to kickstart the cycle of having some actual demos built, people actually spending time on building useful things with Monty, and that hopefully leading to community growth. So that's kind of the idea, that having more demos, more use cases of Monty leads to community growth, which leads to more community members, which has a positive effect on everything. Does that make sense? I said a lot of words, but yeah, kind of the basic premise of trying to focus our both platform quality improvements as well as prototypes and Monty features on increasing the amount of demos that exist with Monty and the community growth.
Is this only going to be for demos, or is it also going to be for prototypes? Like, are they building research prototypes as well, or?
I mean, community members can be building research prototypes, but that wouldn't be the solutions incubator's focus. So it would be more about actually building something where Monty is used in an application. Any other questions?
I have just an observation,
Yeah.
if you don't mind.
Yeah.
I mean, the right hand of the diagram here is a complete unknown to us. We don't know what the first applications are going to be, and
Yeah.
that's typical. That's the way it goes with new technologies. So I think having, and usually typically it comes from someone outside, would be from our community. I think what happened with ChatGPT is, as you pointed out, there was a thing that anyone could use, anybody, you didn't have any technical expertise to play around with it. And I don't know if that's going to happen for us, right? I think one of our first board meetings, I had a colleague and says, well, what's your ChatGPT moment? Like, what's going to be the similar thing for us? I'm not sure we'll have one. It's pretty unusual because, our technology requires interfacing with the world of sensors and stuff. And it's not like you can just sit down in a browser and type something in. But maybe there is. So I think there's a big question mark on the right-hand side here, whether they're going to be the big applications, what will be the kind of applications, what will be the kind of sensors. And we haven't been focusing on that. And so I think the idea of an incubator it's not something we need in the long term, but it's something you could really use in the short term, just to get ideas and have people explore, because that's where we need that. We can build the greatest platform in the world, but someone has to have the insight to say, like, oh, I see how to apply this to something. It's something that's exciting. And that takes domain expertise that we may not have. So in general, I like the idea. We need to sort of gently seed things on the right-hand side here to see what catches. And maybe a lot of those incubators won't achieve anything, but it's still a good idea. Because eventually something will catch. And we can all think about it too, right? We can all think about, like, what would be a really cool way of getting people excited about and people using it in some fruitful way. But that's not our main goal. Our main goal is to build this platform first.
Yeah. And the nice thing about the solutions incubator is that it should require a minimal effort from our side to actually build the demo. I mean, it would require some amount of meetings and communications, but it would be someone external basically building this. And as you said, likely someone who has more kind of domain knowledge of the specific application. And so, yeah, that's a nice thing.
Right. And, we made 220 of these and one or two are successful. I mean, that would be fine. Who knows? I'm just saying it's not like, it's really hard to predict what's going to happen over there on the right-hand side.
Yeah. Okay, so what does this mean for the next year? So what do we really want? We really want Monty to be used in sensorimotor applications to solve real-world problems. I mean, there are so many challenges in the world, and unless we innovate, we're not going to solve those challenges. And I don't think we're going to solve them with deep learning. I mean, maybe some of them can be solved by just throwing a lot of data and compute at them, but many can't. And even the ones that can be, it's usually not the most optimal solution if it requires to burn a bunch of energy and throw a lot of money at it. And so Monty is kind of our bet at the elegant solution to all of these problems. And I think it has immense promise and potential for making a positive impact on all of these applications and more. But we likely won't get there this year. I don't think it's realistic to expect Monty to be used in a real world application that requires actually interacting with the world in this year. But what we can aim for this year is to pave the path for building sensorimotor applications with Monty. And so what we can do concretely for that is figure out the open theoretical questions, especially around using models to manipulate the world. So that's the big kind of open thing of like, how do we actually interact with the world now instead of just moving the sensors to recognize stuff? So hopefully we might make some progress on that this year. Maybe we figure it all out this year. We'll see. And add capabilities to Monty that unlock more interesting applications. That's kind of the focus of the prototypes and integration projects, and the kind of focus of like picking which prototypes to do and which integration projects to do, always keeping in mind of like what applications will this unlock, how much more useful will it make Monty, and then making it easier to build applications using Monty. That's kind of the platform side, platform quality side. What can we do with platform quality to make it easier for people to build applications? And then lastly, actually get people interested in building applications with Monty. One part of that is the solutions incubator, actually offering some amount of money to build something, but then also promoting the project, presenting at various venues, publishing about the project, interacting with people on Discourse, and so on. So the kind of community building aspect of it all, and figuring out how do we get people interested in this approach in the first place, before we have a lot of cool demos, before we have our ChatGPT moment or our different moment. And so going back to this diagram, kind of concrete goals for the next year that I think are doable, or yeah, would hope to see by the end of next year when we do a year review, is figure out theory around causal interaction with the world. So learning causality, learning how to produce actions that cause effects and manipulate the world. Then in terms of prototypes, prototyping our theory that we developed last year around object behaviors and testing if that all pans out. And in terms of Monty features, being able to model compositional models, and we have several prototypes in the pipeline there to integrate and develop further, and then several more kind of theory ideas that we need to prototype and integrate. And one of the kind of subpoints here that we're planning is some kind of publication around modeling compositional models in Monty and the benefits of that. We're gonna scope that in the next month or two and see if we want to do a paper or just a simpler form of publication, but some way to kind of demonstrate the benefits of this. And then in terms of platform quality, there's a lot to unpack there, and Tristan has some really nice detailed diagrams of all that, but I very crudely summarized it now as separate platform, experiment, and environment. Basically, the idea that if you think of Monty's class structure, the platform turns out to only be the Monty class and the classes within it, so learning modules, sensor modules, motor system. And then separate from the platform is the environment, which could be a physical robot, or it could be a simulator like Habitat or MoJoCo, but it's separate from the platform itself. And then the experiment, which kind of wraps around both and controls, for example, the simulator or the setup of the task and how we measure performance and so on. But it's also not necessarily the platform itself, because you might be using Monty in a robot in a factory, and you don't need to run experiments with episodes and epochs and so on. So basically separating these three components out, so it's easier to have Monty as this platform that you can then plug into any kind of environment and any kind of experimental or application setup. And that involves a lot of sub-bullets and a lot of complicated subtasks. And yeah, if you're curious, there's Excalibur boards from Tristan, as well as from me, some more simplified versions of all these items. I can link later on the Slack channel if you want to take a closer look. And then on the community growth side, we have continued documentation of the project. So when people come to the project, they find documentation on how to build stuff with Monty, publications, interactions with the community, and collaborations, like we did in the past year. And then on demos, the solutions incubator, which again, the large chunk of time will be on the external person who receives the grant, but we'll still have to vet people and start this whole program and have interactions with them throughout. And yeah, that's the kind of high level view, top level goals for the next year, if that make sense. If some questions that sound reasonable to everyone.
I think it's a nice summary. It's a nice way of looking at all of it.
Cool. And yeah, thanks to Tristan for coming up with a lot of this framing and also the solutions incubator idea.
Yeah, I agree,
could
Tristan.
never,
You come up.
I could never
Go
come
ahead.
up with the diagram, so thank you for simplifying all of that. It looked more insane
Yeah,
when I showed
we
it.
need our own process with Tristan, moving from his ideas and theory into practicality. How do we make this easier for everyone to understand? You know, just thinking about looking about this, and we're going back to the earlier question about, you know, what will bring our technology into the world. Sometimes you have to wait for new things to occur outside of our world, like new sensors or new robotic things. And you know, one of the things that occurred to me was like drones, right? Drones, I don't know, they weren't a big thing. I don't know, 10 years ago. I don't know. When did they start really becoming a big thing? I don't know. But that's a whole new Sensorimotor platform that lots and lots of people have. And all of a sudden, you know, the appearance of something like that is something that, you know, maybe there's killer applications for our technology require a new thing like that, that hasn't happened yet. And so we may not be able, again, we can't necessarily predict that now. This goes back to the incubator idea. There are probably new technologies and things like drones, maybe drones themselves, that are coming about that where our technology really will take off. And so we have to somehow have ears to the ground or let other people think of those things. Because that may be what's required to have our big moment. You know, something that, oh, millions of people have this, and they all of a sudden can do it, and it's a new thing, and we can make it better.